do some slides here. Where are my slides? There we go. So the first question we really need to get to is, why do I even want a microservice? This is a good example of a microservice. It doesn't do a whole lot. It does one thing, and it does it really well. But it's only ever going to do the one thing, and why do I even want that? This is probably something I don't necessarily need, but there could be a use case for it. So microservice use cases that I have had recently. An email service for a static page. I have a static GitHub page for web devs, and I could have gotten an email. I did have an email set up, but I got rid of it. And I've done it at other places where I need to set up an email service, but I don't. It's all static web page, so there's no server behind it. Like an S3 web page, for example. I can set up a microservice to send the captured form data to an AWS email service, so then I can have a contact form. Bringing in outside API data, which is what I'm going to be doing today. I'm going to be showing off how to bring on just a little outside API data to another place that doesn't already have an integration there for you. Transformation of data from an API. This ended up being something I did a lot with microservices, hooking up two different platforms, for example, that don't have an established connection. I can make a layer of integration with a lot of small microservices and have that completely isolated from the two platforms, so there's no code sharing there and no strong coupling or anything like that. And if you change services, this is very nice, because if you change services from your platform to another, let's say the example I'm going to use today is probably CRM. If you change CRMs, it isn't that big a deal to change CRMs. You don't have a lot of code that you need to go and destroy and clean up. They're all pretty isolated, so it actually makes flexible transitions like that possible. Another use case I had very recently was an ephemeral web page. I needed an ephemeral web page for a project where we were using OAuth and didn't have the website portion built. We were starting with the mobile apps. But I still needed a page for a redirect to land on to link back to the app, and I used API Gateway and a Lambda to serve up an HTML page that doesn't actually exist anywhere. And good benefit there is now this page will never be crawled, it won't be indexed, nobody will get to it on accident. It was pretty good. It solved the problem really quickly. But all this stuff you can already do on your server. And that's usually the pushback I get when I talk about these little small, tiny services, is I have a server. I can do some of this. I can do a lot of this stuff. And it's true, you can do whatever you want with your server. It's yours. You take on a couple things there, though. There's some drawbacks. You're going to start coupling code with other code, right? Your microservices are going to be doing one thing while the rest of the code's doing another stuff. Do they need to live to each other? Do they need to be a part of each other? I mean, probably not. There's more servers to maintain, possibly. If you start tacking on all these little services to your existing your server, whatever application it's serving, you may need to upgrade because of the traffic or the usage or something like that. So you might have more service to maintain at the end of it. There's also some version locking. So your microservices are now only as agile as whatever's on your server, this monolith or whatever application you have. You don't want to be patching it all the time with the microservices, because it'll be hard. They'll all be locked to that version. But this serverless approach also has drawbacks. There's the platform lock. You can't just mix and match AWS and Azure and Google Cloud. They just don't. There's some overlap on how they work, but it's not as easy as just push a button to migrate. This is disruptive to like a normal dev workflow. A lot of times you can't do this stuff on local. You can do SAM local and run AWS Lambda style stuff in Docker containers on local. So that's a good option if you want to do that. But you can't then just like copy and paste to other places. You can't just upload easily without setting up all the CLI stuff. Sorry, that was the point I was on. There's also the platform-specific learning curve. So each one of the cloud platforms does things slightly different. They handle permissions differently. There's things you have to learn about using a cloud provider for these things. So of those services, why even choose AWS, right? Over, let's say, Google Cloud or Azure. The real reason is it's ubiquitous. There's lots of people using AWS. Eugene WebDevs, like I said, use AWS. IDX and 20 Ideas, both represented here in this, also use use AWS. Excess Media does. Technology Association of Oregon, Palo Alto, and Hersner Hunter Attorneys. I don't really know much about them. I just saw that they were using AWS. And these are all local, people around Eugene, companies and stuff around, entities around Eugene, and they're using AWS, so it's probably a good skill to have. And then the other reason is it's free and easy to get started, and there's lots of language support. So you can get started at AWS. You do enter a credit card, but for everything I'm showing today, it's going to be well within the free tier. The Lambdas have a free tier of about 1 million invocations, and API Gateway doesn't technically have a free tier. They do charge you, but they charge you a fraction of a penny. And I think you got to get up to about 1 million before you get charged pennies. So you're probably not going to get charged, and if you are, your service is popular enough that you need to work up a business around it. There's also good language support. Much better language support now in Lambdas than previous years. They added a thing called Lambda layers, which is the ability to add like packages and stuff to your Lambdas, but you can also add a full language, not just a package. So, and in the workshops GitHub repo, there are some examples for various languages: Go, PHP, R, several of them. But today I'm going to be showing mostly JavaScript because this is a web devs meetup, and I figure web devs, even if they curse JavaScript sometimes, are aware of it and can read it. So what do you need to know to even start using a microservice that you figured out you have a use case for? First thing is Lambdas. This is going to be your compute, right? This is a small stateless functions that only they do compute logic, and that's about it. And Lambdas only run on demand. That's another important thing, and another possible advantage over a server. A server is always available. You pay for that time. It's always running. It's all ready to serve. That's what they do. But it's always on. Whereas Lambdas, they kind of go to sleep when they are not in use, and this saves you money. They're not running. You don't have to worry about them doing stuff. They will only run when invoked by something else. So that's their whole deal. They're just little containers with a function in them, and they run. They all have the same function, which is a handler function. You can see this is the most basic. If you just go to AWS and created a new Lambda, you would have this boilerplate there waiting for you. This returns a string of hello, and that's it. You can put whatever functions above and variables above, and then call those functions from within the async handler function, but that's where the business happens, in the async handler function. You do want to put stuff above the async handler function if you wanted to go into a kind of pseudo cache. Lambda has a weird caching thing where it will remember some things even though it's stateless, just to try to speed up loading. So if you have constants that you want to have, keys, I don't know, you can put it above this async handler. But there's always things to remember with everything. But especially with Lambda here, they should be small and stateless. These things are meant to live and die quickly. They are not really suited for long-running processes. They want to do something small. They want to be the nano service to your microservice. Lambdas also sleep, like I mentioned, when they're not used. This is a bit of a gotcha, or it can be. In the example today, we're talking about Slack, and Slack is a chat application, so Slack doesn't like long waits when there's a request. They want to open and close and open and close. So we're going to be tacking on some data from another API, but that means we are going to be slave to the API time of our GET request to this API. This might take a long time, in which case Slack will say, well, I'm not done waiting, and your request will stop inside of Slack. So I'm going to address that at the end with state machine step functions. Not every package will be easy to use. The Lambdas, they run in their own container, and there can be issues. And you might need to find a modified package that works better inside, or made for a Lambda, I should say. I had to do this with headless Chrome. Running headless Chrome inside of a Lambda does work, and you can use it for all sorts of web inspection things. But I had to find one specifically made for Lambda because the default one wouldn't run. Now, I mentioned you probably won't get charged, but you could. So there's always a horror story at like the AWS conference where somebody says that they had somebody who made an infinite loop in a state machine, so you just had Lambdas running 24 hours a day, and it could be at a very, very large scale. And that costs money. If that happens, you should be very careful, obviously, but if that happens, AWS, I hear, is actually pretty reasonable and say, oh, that's probably, don't do that again. And maybe not charge you the full amount. I don't know if that's true. It's just a story that I got told at the AWS conference. It's never happened to me, and I didn't work at a company where it happened. So the other thing you need to know other than Lambdas, is API Gateway. This is just a public HTTP endpoint, and that's it. API Gateway doesn't do a lot. It's really meant to simplify the beginning of an API process for an endpoint you want to expose, and not much more. That's looks like this. It's almost all GUI. You can do some code transformations here in the integration request and the integration response, and that would be the data you're receiving from the HTTP request and the data you're passing back to the HTTP request. But normally or most often, I think I found you just pass data through to the compute portion, which is the Lambda. You can also invoke other AWS services here too, not just Lambdas. So this becomes a very simple microservice. There's a client, which in this case, which will be Slack, but there's any client that can do an HTTP request, a post in this case, to API Gateway. API Gateway will simply receive it and pass it right along to Lambda. Lambda will do some sort of compute and then send it back to API Gateway, who then sends it back to the client. That's it. Single service, single goal in it. It doesn't have to be complicated. But one thing that can make it more complicated quickly is when you start hooking these things up to other AWS services. So I might want to invoke a notification system, one of the simple notification systems, which I guess to trigger an email or something like that with this kind of service. And I can use the Lambda to transform the data, prepare it for the next service, call the next service, add data from another source like S3. So you can really start gluing all of these services together. And this isn't even a good representation of how many services AWS has. It's just a monster. There's like 100 or something crazy. Well, I'm not going to get into the IAM role permissions today, because they're kind of, it's its own talk. They are so, you can get so fine-grained in IAM permissions, and these are the permissions roles to run anything inside of AWS. Every user has their own role with its own permissions, and the services themselves can have permissions on top of them, and there's just it's its own thing. The API Gateway and Lambda services I'm talking about today will run together pretty well just at default. Whatever role you have, you probably can run them both. And in my own account, like most people, I just make myself super user of everything instead of worrying about it. So that's one thing you might want to look up, though. So let's talk about making something, now that I talked about why I think they're good and the pieces that we need. I just want to make a simple / command when I'm in Slack. I want to type in /tacos and then get something back. In order to do this, I will need an AWS account, or if you want to do this, you're going to need an AWS account, Slack account, and probably some API to get some data from. In Slack, it's super simple to set up a / command. It's just / your command, basically. And this will send a post out to get in. This will send a post, and then it will, whatever endpoint you pointed at, API Gateway, and then it'll return the data to Slack. So now our microservice looks like this: Slack, API Gateway, and Lambda. In this case, you can see we're going to be returning some tacos, because tacos. So we'll start with the computation, the Lambda. Just like I showed the function before, this you're just going to compute and return 3 taco emojis. This won't be the end of the service. I'm going to try to give it for a little more than that. But this is just so I can get started and know my connection's done, and once my connection's set, then I can get working on making it better. API Gateway setup. So like I said, this is all GUI. You just create a REST endpoint from a dropdown. I don't have slides for all these because they're just dropdowns, and this would get really cluttered really fast. Create a REST endpoint is simply a dropdown. Actually, you know what? I think I can show it, actually. So let me just transition to that. if we go into API Gateway, it's just drop downs to create a resource. We can name it whatever we want, or if we have a resource already, like the tacos here, or my test, here's a test one that I use for testing. I can add another method by just creating a method, choosing any of the normal HTTP methods. So that kind of creation is really, really easy. And then we have places to set what kind of services we want to go to, an AWS service or a Lambda function or a mock. In this case, I got it set to post and start an execution, and then it accepts application JSON. And in this case, it's going to invoke the state machine. I'll show that later, but normally we just pull this down and do method request pass through, and that will just pass through the data in a structure that AWS has already kind of set up, and then you can work with it further on with whatever service you just pass data to. So, go back to slides. There are some gotchas from the Slack API. Like I said, it doesn't actually send application JSON as its content type. It's going to send the XWW's form URL encoded. It's going to pass everything in a URL string to you. And that's a bit of a gotcha for a couple of reasons when working with AWS. The tester in AWS that's in the API Gateway page only sends application JSON, I'm pretty sure. I don't think it does another one. So you're going to have to use something like Postman to send posts at it. So that's not that big a deal. It's just a little thing that every API, to remember, every API you want to integrate with, like most integrations, are going to have their own idiosyncrasies. The other gotcha, like I said, from Slack is you have to respond quickly, or it's going to just not work. It'll just stop. So I'm going to take care of that with step functions later, because like I said, Lambdas go to sleep and APIs take time to return data. So how do we mitigate that? And I'll be showing that later. So the Slack setup, the last part. Again, it's all GUI. You're just going in, defining a bot, and setting up the slash command. That's it. Point it at an endpoint. Give the slash command a name. Point it at an endpoint, and you're basically good to go at that point. And if we do all those things, this is what we get. You put in slash tacos, you get the 3 taco emojis, and that's I mean, it's a microservice, sure, but we could probably make something better than that. So this is still a very simple contrived example, but even that's not very great. So let's go ahead and look at something else. So what if we want to return recipes? I mean, I like making tacos. I don't always know which ones to make. And yeah, I can Google that and all, but you know, it cuts to be 5 o'clock. I might be, now let's look at some taco recipes when I have a second. Because I like making them. So we can just add a get to our Lambda, because there is a taco API called Taco Fancy that has over 100 taco recipes in it. So I'm going to hit that with my Lambda. This is just a normal HTTP request in Node. This is all happening inside of the event handler, and it returns the promise from the taco recipe. You can see the URL params I set, or the path I set, and the params are for random taco recipes. And that's what it'll return. There's no auth on here, which makes it easy, but you can also have auth here. Lambda supports environment variables, so you can put them there inside your Lambda, or you can use AWS secrets if you have more sensitive stuff. You can even set up another microservice for renewal of OAuth keys if you need that, and it can just store a new OAuth key like every hour or something. But for this one, all I need is just the return on a get. And I get back JSON, which you can see has the name, the URL, more stuff, more metadata about this recipe, and that's great. But it's not very pretty. And presentation matters. Things that look nice, people will want to use. And this taco data is meant for humans. I didn't make this for other machines. Machines don't really care about tacos. I see some taco emojis in the chat. Yeah, fill that up with taco emojis. That's good. So with just a little bit of changing things up, I can then return something that's more human friendly. I'll return the name and the string to the recipe. Then the human can go read the recipe on their own if the name sounds like an attractive taco prospect. So now I have a microservice that returns a piece of data, and the data may be useful, and it's pretty small, and I didn't need to waste server space or set anything else up connected to any larger applications for this. And while it is very, it's a pretty trivial task to go look up tacos, I think the takeaway I wanted people to have is that this approach allows not only for taco recipes anytime, but it opens the door to a lot of other things. It's going to start opening the door to integrations with other services, like I was talking about. You could do an entire layer of transformation of data from one source to another, aggregation of data from several sources into one thing. You can start invoking other AWS services, all of this in a serverless fashion that is not coupled to your other code, isn't going to disrupt your application if something happens. Each Lambda is isolated, so if there's a problem with one of them, you just know which one it is, and you don't have to really hunt it down. And there's a lot of reusability in this pattern. You can have one API gateway that handles a lot of things. You can have several, whatever you want to do. And that's the takeaway I think I want to show is the idea of how flexible this is for a lot of tasks that do come up. But I mentioned earlier about something more complicated, like having to deal with an idiosyncrasy of Slack and its wait times. So this is where we start bringing in step functions. And this really unlocks like the next level too, for data transformation, aggregations, and things of that nature. You build a state machine. Your state machine is going to look like this. This is a diagram that AWS gives you, and it takes in JSON and passes the JSON to the first, and then whatever you want to do after that, Lambdas. So each one of these green squares here is a Lambda, and there is routing built in to the step function state machine, and that routing is all set up in just one JSON file. So you're writing a complicated machine with very little code, because all the decision logic here on which Lambda to run is just stored in one JSON file. All of the Lambdas have their own function, like you saw earlier, really small functions. And your machine will get invoked by API gateway or something and do more complicated processes that run a bit longer and then can communicate with the rest of AWS or any REST endpoint. So if I move my tacos microservice to step functions, it looks like this. This is the diagram for my step functions. You see they're all green, that means they all worked and pass data to each other correctly. It's nice that step functions will show you which ones work, and when they fail, it shows you where it failed. This makes it really nice for debugging and really easy to work with. This also means that this one microservice didn't disrupt any other microservices when it failed, and it didn't disrupt your main application when it failed. But that's all fine and good, but let's look under the hood for microservices here. Let's transition to the AWS view. Where's that? All right. So back in AWS land, we have got our API gateway, and you can see I have this one. This is my test one, but I think the recipe is also set to it. This goes to step functions. So instead of invoking Lambda with my request, which is one of my options here for an integration type, number one actually, because it's so common. Yeah, I've got it set to invoke a state machine. This is the Amazon resource number for that state machine, my taco state machine. What that does is when the Slack / command calls this API gateway test or recipe, I think it's the other one, it will go through the method request, the integration request, pass the data to the step function. The step functions will take the data and get started. It gets started immediately, but it will return a 200 right away that it started. It won't respond to the / command. This way, the / command gets its response almost immediately, but because Slack is going to pass me a return URL, a URL for me to respond with for longer running processes, that means my step functions can work on whatever, and I've got more time. Those things last like 15, 20 seconds or something like that. So I've got way more time than a couple seconds to respond, because I now have a ephemeral URL that I can use to post back to for my /command response. It won't change the service in any way. It just kind of time proofs it from Lambdas being slow to start and APIs taking a long time. So what does that look like? What does this actually look like? Our machine here. And actually, I'll do an execution. This is the JSON that Slack would post from a / command. And you can see everything's passed in a query string here. Tokens, this is all expired, so you can't steal the tokens, so don't worry about that. But one of the things it passes is a URL, temporary URL for me to respond to. This would be the response URL. This is just the hook that's waiting with a big long string and response URL. So my Lambdas just need that in order to respond. And if I run it, Lambda's cool enough, or state machines are cool enough to show me which Lambdas are waking up and running. This gets, and the color codes them actually. So the green one's already passed. Everything passed and things worked. Great. Nothing turned red. That's great. So what does this configuration look like? Well, if we go to edit state machine, we can see that it is just a body of JSON that has a list of steps and functions to run, hence the name step functions. Each one of the ARNs here, resources, is a different Lambda. And this will just run in the order I tell it. I can even introduce logic here, if statements. The state machine will read every response from every Lambda, and that makes it able to make these decisions. So if I want to say continue or no, or skip to the end if there's some exception, or some sort of the API response was 0, HTTP response body was nothing, I can check for that and then say skip, and then my state machine will be smart enough to check that variable I'm passing and skip to the end. So this is it to create the state machine, and this is also very little code. It's easy to maintain. It's just, you can store these in GitHub or wherever. It's just a JSON object. And one thing that's really nice here inside of state machines is the ability to reuse Lambdas. So the get taco data is a generic request HTTP. It's one Lambda, and I use it twice. And I found this to be really useful when you have like a lot of data you want to integrate, like from a CRM from your platform to another platform, and you're going to be doing a lot of transformations and a lot of calls here or there, or aggregating data from several sources. It's nice just to write the REST request once and use it across this state machine or another state machine, or several times in one or more state machines. The rest, just prepare the strings for the next Lambda. So this would be the /request, and yep, this would be the /request, and you see I get the query string, and I get that response URL. Now, since this is the first Lambda, this get params from Slack, I have already set it up to have the response URL that I'm going to need later, and I also set the host and the path for the API I want to use. This then passes to the get taco data, which is just a generic request. I moved the HTTP request to its own function up here, and now I get from the event, I pass the host, the path, the method, and the event data if there is any. In this case, there's not, but I use that later to post. And then I pass the incoming event in the response of this Lambda. And the reason I do that is so that way the response URL that was in the incoming event still gets passed to the subsequent Lambdas in my state machine, which would be this return data. So in the return post, I'm going to grab the, let's see, oh, I have this set to go to a webhook. That's why it worked, because that token, otherwise that Slack URL is expired. So yeah, I'm going to grab whatever params I need from the previous Lambda, and then I'm going to do a post with it and send the data, the response URL, if it was a valid one. And that's it. Now I wrote 3 Lambdas, I've got 4 steps, and my state machine now responds quickly and easily to Slack, and I can start building off of it. I can even call other state machines. So that's all great, but one of the things that happens is these get a bit unruly. You start making a lot of them. So planning them out is really, really important. It's great to make little slash commands here for like ease of life, tacos. I did one at IDX that was what was for lunch. Those are great. But when we started getting into using it as a layer for integrations, more planning, a little planning goes a long, long way. So that's my presentation on this, and a little bit of code demonstration. Normally, I'd be taking questions right now. I'm happy to take any questions in the chat, but there will be a pretty healthy delay. So just keep that in mind. And if anybody else is wanting to, wait, Alan, did you post a burrito? Is that what you did? I just noticed that. This is about tacos, dude. This is about tacos. So I am planning to do some, hopefully more presentations like this, like kind of, but a little more code along. I'm still trying to figure that out. I've got a couple ideas for some workshops on a couple topics, and this is totally subject to change because my time is, it's finite like everybody's. But the next idea I have is probably for Storybook, and if you haven't used Storybook, check it out online. It's it's really made for React, but it's an interesting way to do style and create components in isolation. So it's interesting. Another idea I had was Chrome DevTools, like an intro to mid-level Chrome DevTools. That one I really want to be more of a code along, so I'm trying to figure out how that's going to work. And then another idea I have is progressive web app, like what is the shortest path to a progressive web app with a database. That will be very interesting, I think, if I can get it to work, especially in a digital format where we're not in person and I can't have you install stuff. So yeah, those are what we got going on. Let's see. Tacos and burritos. Yeah, Alan. I mean, yeah, I'm not going to say no to tacos, burritos, and tamales. You raise a good point, Alan. But yeah, so thanks everybody for coming. I hope I'll be able to do some of these stuff. Let's if anybody has any interest in helping out or any other ideas that they think might make a good one of these for web devs, hit me up. Ryan says, "Who's up down for margaritas and tacos after?" I mean, I am. I mean, margaritas and tacos. Yeah, that's going to be a constant yes for me. I'm going to leave the chat up here for a little bit. It looks like I don't know if anybody's. Alan is fired. Alan, you got canned, bro. Oh, that's funny. Yeah, this was an interesting thing. I don't know how everybody feels about them. Let me know in the chat, I guess. Let me know in the comments here on YouTube or whatever. I'm supposed to say like and subscribe, right? Like on YouTube? Do this? That's the thing I'm supposed to be doing? It'd be nice to do in real life stuff again someday, like I said, but I'm not even going to consider that until it's safe, and that probably won't be until sometime next year, so. Unfortunately, this is the situation we're all in, and I don't know. I thought this is okay, and if everybody agrees, let me know. Let me check the chat real quick. Nicole has to put on pants. Yeah, do that. Put on some pants. Jeez. So it's interesting doing stuff on YouTube. It's so different. I'm really also trying to figure out what kind of tools I can use for interaction. I did this presentation internally at work, and I had already installed this Taco microservice. So at the end of it, it was really cool to tell everybody, oh, I'll also try this out right now. I didn't get this installed because there's not one place. I can't install it in YouTube chat, but I do like for the Chrome DevTools. Was there a Slack demo, David? Yeah, I mean, there was a Slack demo at work, but I could probably do it right now. Let me bring up my Slack. Where am I? Here we go. I'll just come up. Where's David? What? Am I in the right Slack? There we go. Actually, is it still installed? I don't even know if it is. Let me make sure that it wasn't uninstalled when I wasn't looking. Oh, here we go. Oh, that's the wrong one. There we go. There's a recipe right there for Asian style tacos. And then looks like I returned the same one. What if I do it again? It is random, so sometimes it does return the same one over and over again. There we go, chorizo scramble. What do I get this time? Moroccan lamb. So lots of recipes in here. First time here, Will, huh? Oh, that's awesome. I'm glad you like it. Try to come up with good topics. Try to always look for some new stuff and some existing stuff. The web devs is also one of the things I've always tried to do for my presentations and encourage everybody to, is to provide a repo of your code. I know going to presentations, a lot of times people will take pictures because they want to save the code, and if that's a thing people want, just give them the code. I firmly believe in that. So, like I said, and just say again for anybody who wasn't here at the beginning, all the code I showed, including these configurations for like the state machine, are in the GitHub repo, which will be in the comments or description for this video later. But they're already posted on the Meetup page. So if you go back to the Meetup page where you RSVP'd, that link is already there, and it's just the workshop link. You can also find the GitHub repos, all of them for Eugene Web Devs at eugenewebdevs.com. There's a link there to GitHub. Yeah, now we got those tacos. I'm glad you like it, David. I'm really hoping somebody makes tacos and it tells me. Like, I'd like to see somebody make one of the more out there ones. There was one with like some charred tacos that I was like, I don't know how good that would be, but I mean, I still have margaritas and those. I'd still say yes. Like I said, it's pretty much standing yes for me. Let me check stream real quick. Oh, here we go. Here's a question from Ryan. How does one implement automated testing with lambdas and step functions local stack? So you can set it up on a local stack. If you want to set up automated testing, you can. Well, I guess what kind of testing? Do you want to test each lambda, because they don't always make sense by themselves, and they're really easy to unit test that way though. There's an expected input and output every single time. You can invoke any of the lambdas you want if you set up a service for that as well. And you can also, I think, auto test them in is it code deploy? Code star? One of those that you can then run tests on that you have set up. I think it's maybe code star. I don't remember which code service. One of the code services, I think, will do it. Just like when you have a GitHub repo or whatever, it will run tests on that for you. Let's see here. Nicole doesn't use recipes for tacos. I mean, that's fair. That's fair. I don't usually use recipes for tacos, but this is an interesting idea of, I don't think I've ever made tacos with lamb, for example, or definitely not charred. Chorizo, I don't usually think of as a taco thing. That's more of a breakfast thing, although I do turn most of my breakfast into tacos. Let's see here. Ryan says, when deploying a set of lambdas and step functions, I want a build step that lint, test, and deploy. Yeah, so lambdas also have their own versions, each individual one, and I think that's part of the thing that disrupts the normals, some of the normal flows here. So if you're going to test them, some lambdas are I would say, are very easy unit tests, right? Like all in version, of course. Yeah, Lambda has version control for each and every Lambda. But that being said, you'd be writing a test for every single Lambda and then running it in its own version in one of the code services here in AWS. You can also do it on local, I assume. I haven't set up, when I was using Sam's last, it did not yet support step functions, but it does now. So you can test them on local as well and have tests that come with whatever repo you have of a state machine. And then that when that gets deployed back to like CodeStar or something, it will run those tests. Yeah, sometimes you do have to fiddle with them one at a time, Ryan. He says he doesn't want to fiddle with them one at a time. And now he wants to work on multiple and confirm that it don't break anything, which makes sense. Which is why you'd write a test for each single one, and then maybe an end-to-end test, something for the machine itself. Also, it gets a little different because these lambdas can exist in multiple state machines, so that might affect your testing. What else we have here in chat? Let me scroll back up. I haven't. Tacos are real deal. Corn torts. Yeah, corn torts. I mean, yeah. Scroll back up real quick, see if there's any other questions I might have missed. CM code snippets. Yep, like I said, all the code's in the repo. And I shared it earlier. I'm going to share it again in the chat. Ryan says thumbs down. I mean, that's fair. Like you said, you want to work on multiple. Well, what if there's one, Ryan? Like, in my example, there's only like 4. In the beginning example, there is only 1. So these are meant to do small things, I think. And when they get really, really big, that is a harder thing to deal with. And at some point, you know, if your services are being called like constantly, maybe this isn't a good approach for you. Like if you need services that are pretty much running nonstop, it might be better to do an EC2 instance and just have a server that runs nonstop. But if you need something that's a service that's only going to be called once every, I had a service that was called once a year, and it was just a cleanup service. So this worked out great because there was no need to throw it on a server that's going to run and be charged for an entire year. It just ran once when it did its cleanup, once a year, because of the it was a log cleanup service, and that's all it did. But it also meant somebody didn't have to remember to do that. We set up a CloudWatch event, and it just fired off once a year. Why is the state machine model a faster respond to Slack in this example? So it's a faster response in that the state machine gets invoked and just says that it got the data and it is working on it. It is the data itself from the API or anything doesn't happen any faster. And that you can't control that because it's somebody else's API. But when you the API gateway will invoke the state machine in this example, and that's all it cares about, that the state machine was successfully invoked. It is not waiting on a response, so that means API gateway is then free to respond to Slack with a OK, and then use the response URL for a response to the / command later. Hope that makes sense. Nicole, I do shove breakfast into a taco. I also get breakfast tacos at the coffee shop down the street, Moke's, on 13th and High. If anybody wants to get breakfast tacos there sometime, totally down. Just a couple blocks from where I live. Oh, I was going to grab the, real quick, right, the GitHub. Put in here. Okay, so I'm glad that answered your question. Let's go to let's just go to eugenewebdevs. I hit GitHub workshops. I'm just going to paste this workshops link in the chat. So if anybody wants to look at the code stuff, I pushed it up earlier. I'll look at it again. I already got a couple places I think I could explain things a little bit better in the README. So a lot of these workshops and a lot of my repos are work in progress as I come up with where I figure out what I could have done better. So also, like with all of these things, pull requests are welcome if somebody has input on these, on how to get them set up. Feel free to fork in and do PRs. All right, let me check the chat one more time. Somebody commented pizza. You're way off. This is the wrong live stream. Let's see. Noah says, I don't think Slack would eliminate that lag. It's the video that has delays, not the chat. Yeah, oh, the video that has delays on the live stream, I think you're talking about. Yeah, I agree. Not sure what that means, but Slack would eliminate the lag. It's the video. Oh, okay. You were talking about that lag. Yeah, the video does lag. Any other questions? I'm still gonna hang out for. I'll probably hang out for another like say 10 minutes or so. I don't want to keep everyone's time. We're all on video stuff like crazy these days. I hope this was informative for everybody, but nobody needs to hang out on my account. So Alan says Zoom also has integrations, more real-time reactions. Yeah, I like the idea of maybe doing Zoom for something that's a little bit more hands-on and using breakout rooms for like peer coding. I might do that with either Storybook or the Chrome DevTools workshop I want to do, where people maybe I can get some volunteers. And oh yeah, no, sorry. Okay, cool, thank you. Noah's response was for Philip, not for me. But yeah, I might try to do some have breakout rooms available if I can get some volunteers who can just hang out on a Zoom and help people with Chrome DevTools stuff. Oh, also, and maybe some of the other ones that are going to be more hands-on install stuff. I'm really trying to figure out a way. Like, I've been to workshops where we're waiting on somebody to get for their npm install to finish or something like that, and it's just like I like the idea of if it's going to be virtual, then like having many people so people can work at their own pace and work on the parts they're interested in, get past maybe a certain point and be like, this was the sticking point for me, something like that, instead of having to wait in a group like in real life. But I am still workshopping how I'm gonna try to present that. Zoom does have some options. Like I said, the breakout rooms are a really good way to have like a main lobby and say, hey, if you want some one-on-one peer programming, hang out in the lobby, raise your hand, and hopefully somebody who's going to be a volunteer for that event can peer program with you one-on-one. And I think that's a good thing. I'd like the idea of people getting chances to mentor other people as well. That a lot of that went away this last year. So bringing in places for people to get mentorship I think would be really, really valuable. The coverage feature in DevTools. Oh, so it sounds like, correct me if I'm wrong, Chad, but it sounds like Alan just volunteered to be a mentor in these rooms I was just talking about. It's what I'm reading from that, Alan. Actually, if anybody else wants to volunteer, it'd be great. I do like that idea. I don't know. We lost a lot of places where that happened. Down in Eugene in person and stuff. And with somebody who was on that was in your time zone, that worked on stuff, that was part of the community. We lost a lot of that. So I don't think this would replace it, but I don't think it hurts. Okay, good. Confirmation from Alan for sure. He is. So yeah, get around to doing the Chrome DevTool ones. You can have Alan peer program with you and help you work through debugging stuff. I've got some ideas for that, Alan. I will hit you up later on and show you. Or if I haven't already showed you my ideas for that kind of code along workshop. And especially if you have insight or some good ways to add to it, that'd be great. Especially you said you've been using that portion of DevTools a lot. The coverage feature. Let's scroll back up. Oh, also, if there's any other peer programming stuff, tools I don't know about, leave them in the comments. I'll check them out. Are there ways that people are sharing stuff? I've seen VS Code share things. GitDuck I checked out, and some of these might work for small things like small one-on-ones. Maybe it doesn't work at your organization or something. You're too big or something like that. But I definitely don't know all the tools out. I've been learning a lot more about YouTube and OBS and all that stuff lately. But yeah, code collaboration stuff would be good, especially with audio and stuff, audio, video. Okay. Been using it lately for Google Core Web Vitals. Interesting. Could be a good thing to throw in. Yeah, I'm also looking for any and all suggestions on any of these workshop topics I just said, or I guess another one. I'm probably only gonna do them, like I said, every other month, so there's only really room this year for like 4. This one's already happened, so it'll be tight fit if I want to change things around, because it just takes a while to set everything up with time. Unless other people want to start doing them, and I can figure that out. I would be interested in that too. Like, how do I get a guest on here? I haven't figured that out in OBS yet, so I would also appreciate any OBS help. Anybody in the community has, that'd be great too. All right, I'm not seeing a whole lot more in the chat, so I think we're going to end the stream now. 6:55. Like I said, I don't want to take up everyone's night, so thanks again, everybody, for coming and checking this out. The video will be up shortly for this live stream. I'll do some edits today or tomorrow, and in case you want to reference this again, but you probably want to reference the GitHub workshop, and I'll be working on that over the weekend because I have some README changes I want to do now. Thanks again, and hope to see you guys again soon. Look for the next meetup announcement on meetup.com like you did in this one, and see you.